Section 5.8, the quadratic formula. In this chapter, we have used factoring, graphing, square roots, and also completing the square to determine solutions to a quadratic equation. The quadratic formula is another method. If we have a standard form of a quadratic equation, which we know is ax squared plus bx plus c equals 0, it can now be solved by using the quadratic formula. This is the quadratic formula. X equals a negative b plus or minus the square root of b squared minus 4ac all over 2a. This can be derived by completing the square on the standard form. We'll leave that for later in the section. We also know from the standard form that a is the coefficient of my squared term, b is the coefficient of my linear term, and c is the constant. Once I know the value of these, I can then substitute into my formula and derive the solutions for x. Also, we must notice that since this is a plus minus, I'll have two solutions just like I have when completing the square. Also, if we take a look at inside the radical, we'll have an expression, b squared minus 4ac. That expression is known as the discriminant. That's the discriminant of the quadratic trinomial. And this discriminant, that expression, can help us determine the number of real roots of the quadratic expression. For example, if b squared minus 4ac is greater than 0, my graph of that equation would look something like this. And that would generate two real solutions and also two x-intercepts. So that can help me make estimations of my solutions for x. If b squared minus 4ac is equal to 0, then my graph of the quadratic function that I have would look similar to these two. In other words, my vertex would be on the x-axis. And that means I would have one real solution and one x-intercept. And that would both be the vertex of my equation. If b squared minus 4ac is less than 0, that means I would have a negative real number inside my radical, which I know generates imaginary solutions. That means I would have 0 real solutions and 0 x-intercepts. The graph of that equation would look similar to these two graphs. I would have a vertex that is above the x-axis and opening upward, means I would have no solutions and also no x-intercepts, or I would have a vertex below the x-axis and opening downward. Again, I would have 0 real solutions and 0 x-intercepts. Here's the procedure to solve quadratic equations by the quadratic formula. 1, put the equation in standard form. 2, identify a, b, and c. 3, substitute a, b, and c into the quadratic formula. And 4, simplify. Also, keep in mind that we always want to take a look at the discriminant so we can estimate what our solution will look like. For our first example, solve by using the quadratic formula. And as always, I like to determine solutions by using the discriminant. Here I have 6x squared plus 7x minus 5. We know a is equal to 6, b is equal to 7, and c is equal to a negative 5. Now I just substitute in. I'll have x equal a negative b, and I know b is 7, plus or minus the square root of b squared minus 4 times a times c. And that is all over 2 times a. Now I just simplify. That's going to give me a negative 7 plus or minus the square root of, and I'm going to have 49 minus, here I'm going to have 4 times 5, which is 20. 20 times 6 is 120. And a negative times a negative is going to give me a positive. And that's all over 2 times a, which is going to be 2 times 6, which is going to be 12. If I take a look at my discriminant, it is positive. That means I'm going to have 2 real solutions and 2 x-intercepts. Now I need to simplify further. That gives me a negative 7 plus or minus the square root of 120 plus 49 is 169, all over 12. Then I simplify again, and I know that's a negative 7, plus or minus the square root of 169 is 13, all over 12. Now what I do is I generate two values for x. My first equation is going to be x equals a negative 7 plus 13 over 12, which when I simplify, negative 7 plus 13 is a positive 6 over 12, which is 1/2. And my second equation is going to be x equals a negative 7 minus 13 all over 12. And when I simplify, that's going to give me a negative 20 all over 12. And again, I simplify. That's going to give me, I'm going to divide both by 4, which is going to give me 5/3. So we have my two real solutions and two x-intercepts at 1/2 and negative 5/3. On my next example, I have the product of two binomials. I need to FOIL that to get my quadratic equation in standard form. That's going to give me 2x squared plus 2x minus 5x minus 5 equals 2. Let's simplify. That gives me 2x squared minus 3x. And when I bring over my 2, that's going to give me a minus 7 equals 0. My a is 2. My b is a negative 3. And my c is a negative 7. Now, all I need to do is substitute into my quadratic formula. And we want to keep in mind about my determinant to estimate what my solution for my x values will be. So when I substitute, I'm going to get a negative b, which is going to be a negative 3 plus or minus the square root of b squared, which is a negative 3 squared, minus 4 times 2 times a negative 7, and that's all over 2 times 2, which is 2 times a. Now, let's simplify. That gives me a negative 3, which is 3, plus or minus the square root of 9 minus 4 times 2 is 8. 8 times 7 is 56. And negative and a negative is going to make this positive, all over 4. Again, when I simplify, that's going to give me 3 plus or minus the square root of, and I'll have 9 plus 56, which is going to give me 65, all over 4. And I know that this is a positive number for my discriminant. That tells me that I'm going to have two real solutions and two x-intercepts. What I have to do is create two equations. That's going to give me an x value of 3 plus the square root of 65 all over 4. And this is already in simplest form, so I'll have to leave it this way. And my next equation is x equals 3 minus the square root of 65 all over 4. Again, this is in simplest radical form. So my two solutions and two x-intercepts are 3 plus the square root of 65 over 4 and 3 minus the square root of 65 over 4. On this example, they want me to solve by using the quadratic formula, find the exact solutions, which means I leave it in radical form unless I can simplify it. and then also approximate the radicals by rounding to the nearest hundredth. That means I need to substitute into the calculator. Let's put this in standard form. I'm going to have x squared minus 3x plus 4 equals 0. My a is equal to 1, b is a negative 3, and c is equal to 4. Also, I'm going to take a look at my discriminant to estimate my solution. So I substitute. I'm going to have x equal to a negative b, and it's a negative 3, plus or minus the square root of b squared minus 4 times a times c, all over 2a, 2 times 1. Let's simplify. That's going to give me negative 3 is a positive 3, plus or minus the square root of 3 squared is 9, minus 4 times 4 is 16, times 1 is 16, and that will be minus all over 2. X equals 3 plus or minus the square root of 9 minus 16 is going to give me a negative 7 all over 2. If we look at my discriminant, it's negative. That means I'm going to have no real solutions or x-intercepts. And I'll have 2 imaginary. So let's take a look at those 2 imaginary solutions. My first equation, x equals 3 plus, and I can simplify this, break this into factors of negative 1 and 7. That gives me I, square roots of 7, all over 2. And my second equation, x equals 3 minus I, square roots of 7, all over 2. This is finding the exact solutions in proximate radical form, and that is done. Also, we notice they are imaginary numbers. I cannot plug these into the calculator since they are imaginary. On this example, I worked most of the way through. Here I have x squared plus 6x minus 5 equals 0. I have a, b, and c. I substituted in. And when I simplified all the way down, I ended up with a positive discriminant. That tells me that I'm going to have 2 solutions and also 2 x-intercepts. And then I broke this into 2 equations. This one being x minus 6 plus 2 square roots of 14 all over 2. And when I solve that, that's going to give me x equal to, and 2 must go into both. That's going to be a negative 6 divided by 2, which is a negative 3, plus 2 divided by 2. That leaves me 1, and that gives me the square root of 14. So one solution is x equals a negative 3 plus the square root of 14. Now I needed to substitute that into the calculator. When I did, a negative 3 plus the square root of 14 is 0.74. So that gives me 0.74. If I could not simplify, I'd have to enter this into the calculator with parentheses for my top expression, then divided by my bottom expression. For my next one, I'm going to have x equals, and again, 2 must go into both. This is a negative 3 minus 2 divided by 2 is 1, square root of 14. And I mean, 2 has to divide into both whether it goes in evenly or not. Or I can leave it as an expression like this. And in either case, when I enter this into the calculator, since I need a estimation, I'm going to get a negative 3 minus the square root of 14. I get a negative 6.74. Again, if I couldn't simplify, I'd have to put this into a set of parentheses in the calculator and then divide by 2 to get my approximation. On my next example, all they want me to do is to look at my discriminant and determine the number of solutions and determine if they are real or imaginary. We've been doing that all the way along. So this is not going to be very difficult. I have A equal to 1, B equal to 12, and C equal to 36. That's going to give me B squared, which is 12 squared, minus 4 times A times C, which is 36. 12 squared is 144. Negative, and it will remain negative. 4 times 1 is 4, and 4 times 36 is going to give me 144. 144 minus 144 is 0. And if we recall, when my discriminant is 0, that tells me I have one real solution and one x-intercept. As a matter of fact, that tells me that my vertex is actually sitting on the x-axis. That's how I get one real solution and one x-intercept. In my next example, I have A equal to 4, B equal to a negative 8, and C equal to 1. When I substitute into my discriminant, I'm going to get a negative 8 squared minus 4 times A, which is 4, and C, which is 1. That's going to give me 64 minus 16, and that will remain negative. And what I'm going to do is take 64 minus 16, which is going to be 48. And this is greater than 0. That tells me I have two real solutions and two x-intercepts. Again, I want to take a look at my discriminant, so I need to put this in standard form. 3z squared minus 2z plus 1 equals 0. I know my b is a negative 2. Minus 4 times a, which is 3. And my c is 1. That gives me 4 minus 12. That's going to give me a negative value. So my discriminant is less than 0, so that tells me I have no real solutions. And also no x-intercepts. But I do have two imaginary solutions. In this example, they want to solve each equation using any method. That means I could factor, graph, use square roots, use a quadratic formula, or also complete the square. Here, what I'm going to do is add 72x on both sides. That gives me a negative 8, x squared, plus 72x equals 0. What I notice is that I have common factors that I could factor out, and that will help me solve this problem. So what I can do is factor out n negative 8x. When I do, that leaves me x minus 9. Now I can use the 0 property. That gives me a negative 8x equal to 0. Therefore, x is equal to 0. And also, x minus 9 is equal to 0. And therefore, x equals 9. These are my two solutions. Here, I think I'm going to take the square root method to divide by 2. That gives me x squared equals 72. Take the square root of both sides. That gives me x equals plus or minus the square root of, break this into a product of factors, 36 and 2, one being a perfect square. That gives me x equal to plus or minus 6 square roots of 2. On this example, I have a proportion, so what I'm going to do is cross multiply. That gives me x minus 3 times x minus 1 equals 2 times a negative 3, which is a negative 6. I need to FOIL. That gives me x squared minus x minus 3x plus 3. And I'm going to add 6 to both sides because I need to set that to 0. And now I'm going to simplify. That gives me x squared minus 4x plus 9 equals 0. I look to see if I can factor, but the factors of 9 or 3 and 3 won't give me 4, and 9 and 1 won't give me 4. So I think what I'm going to do is use the quadratic formula. Recall that is a negative b plus or minus the square root of b squared minus 4ac all over 2a. So when I substitute in, I'm going to get a negative b, my b is a negative 4, plus or minus the square root of b squared, negative 4 squared, minus 4 times a, which is 1, and c, which is 9, all over 2 times a, which is 1. Let's simplify. That gives me x equal to 4 plus or minus the square root of 16 minus 4 times 9 is 36, and that will stay negative, all over 2. And that simplifies to 4 plus or minus the square root of a negative 20. So my discriminant is less than 0. So I'm going to have two imaginary numbers, no real solutions and no x-intercepts. But I can simplify this into two equations. There are going to be x equal to 4 plus, and I can simplify this into the square root of a negative 1 times 4 times 5 all over 2, which will give me 4 plus 2i square roots of 5 over 2. Since 2 goes into both, I'll simplify that into 2 plus I square roots of 5. My next equation, x equals 4 minus, and I can break that into a product of factors, again, as negative 1 times 4 times 5 all over 2, which will equal 4 minus 2i square roots of 5 all over 2. And since 2 goes into both, I can simplify again. 2 minus I square roots of 5.